Good day everyone. Alright, so today in this video I want to talk about circular motion, cases for circular motion. Alright, so three cases that we'll consider. The first one being horizontal circular motion, the second one being vertical, and then the last one would be the conical pendulum. So the conical pendulum is sort of in between the horizontal and the vertical, right? So let's say you take a side view, right? If you take a side view, the horizontal will look horizontal, and then the vertical will look like that, and then the conical pendulum will be somewhere in between with an angle, right? Okay. Alright, so let's look at the first one. Let's look at an animation of how we can visualize the first case, which is the horizontal plane. Alright, so as you can see, the object is on a table, right? And it is going, right? It is following a path that is horizontal. Okay, it's a path on the plane that is horizontal. Okay, so how can we model this, right? So how can we model this? So let's draw it out. So this is our top view. If we look from the top, we will see that the body just now it will go circular in the circular path, either clockwise or anti-clockwise. And then from the side, this is what we'll see. Okay, which is great. So now what do we do? Well, we can say, because it's on a table, right? Because it's on a table like that, then you will have weight down here. Let me just show you that. There we go. We have weight and we have the normal force, right? So because it's not moving up or down, like, or in other words, it's not moving in the y-axis, we can say that it's going to be N equals to W, which is equals to mg. Okay, and as you can see, this Fc, right, we can just remind ourselves that this Fc is equals to mv square over r. Okay, so those are the two main equations that you will need for this particular case. All right, it's a very general case. It's relatively boring, but it's a good tool to have, just to remind yourself that, hey, centripetal force is mv square over r, and then in this particular case it's not moving in the y direction, so the normal force is going to be the same as the weight. Okay, and then, so let's look at the second case. The second case is where you have the vertical plane. All right, so here's a great example, which is the loop-de-loop. I call it the loop-de-loop. So let's look at what happens. It goes down, comes up, and then falls back down. All right, so here, right, instead of traveling in the horizontal plane, we are traveling in a vertical plane. All right, so you can imagine that the weight is going down, and the movement or the circular motion or the circular path is affected by that weight. Okay, is that right? Okay, so let's look at how we can model this. So here's the side view of what we have, which is what you saw just now, the loop-de-loop going up and then coming back down just like that, and it follows a circular path. And if we zoom in on this particular path, and this part of the path, right, what we'll see is this, right? And then we have the normal force because it's on a track, right? It's on a track. And then we have the normal force, and we take an angle with the vertical. So this is the vertical. All right, we have weight traveling in the same direction as the vertical, so this is going to be parallel to each other. And then we can resolve, or we can split this weight up into the one that is along or in the same line with the normal force, and the one that is perpendicular to the normal force. All right, so this is in line, and then W sine theta is perpendicular, and that angle is theta. See, because these two are parallel, so the vertical line and the weight and the direction of weight is in the same direction. So now what can we talk about it? Well, again, it's great to remind ourselves that Fc is equals to mv square over r. Okay, so if you think about it, it is going to be along this line, right? And what contributes to that is going to be equals to n minus w cos theta. which is, again, you can just remind yourself, okay, W is equals to mg, so you can say that, okay, Fc is equals to n minus mg cos theta. Okay, all right. So that is the case that you have for vertical plane. So let's say you change it with a string, right? If you have it with a string, then you will just substitute this n for t, tension, right? So Fc equals to t minus mg cos theta if you have a string. Okay, all right. So the last case that we want to look at is actually the conical pendulum. As you can see, if it is horizontal, it will be moving on top here. If it's vertical, it will move along this plane. But because it's in between, we have a case of conical pendulum. So it moves like this, it moves at an angle. Okay, of course, we'll be looking at a more general case in a sense that we may not assume it's definitely tension. It could be normal force, for example, a banked curve, right, for a car. So let's try to model it by drawing it out. So say we have some force that is moving up. It could be tension, it could be, so this could be tension, or it could be normal force. Okay, and then we have these measurements, which is the height from the center to the plane of the circular motion, and then you have the radius from the bottom here to the body. Okay, to the body. Well, we also know that there's going to be weight. That particular particle or body is going to have some weight, and we can resolve F into its components, which is F cos theta, and then there should be F sine theta here. So this should be F sine theta as well. Okay, so now what can we do? Well, for one, we know that because it's not moving in the y direction, we can immediately say that it's going to be F cos theta equals to mg, or equals to weight actually. Okay, so again, this F could be tension, could be normal force, right? And then if you look at F sine theta, it is actually the same direction as your Fc, or your centripetal force. So your centripetal force is going to be your F sine theta, right? And then again, this is going to be equal to mv square over r. Okay, of course you can calculate F if you want to. You know, there are many ways to do it, and then one of it is probably the simplest one, is just to take this, divide it by this, and then you cancel out F, you get tangent, and so on and so forth. Or you can use trigonometric identities. One way to do it is to remember sine square theta plus cos square theta equals to 1. Right? That should give you a value of around F equals to mg, and then the square root of 1 plus r over h squared, and then square rooted. So that would be a great exercise, though it is a bit too advanced for your liking, or at least for the matriculation level. All right, so that is the end of our lecture today, or the lecture, sort of the lecture video today, and I'll see you in the next video. Thank you.